And our main challenge, that is how to program large real-time systems as efficiently as possible. And after many experiments, we decided that we had to move from conventional high-level languages such as Ada, CHIL, C++, etc., into the world of declarative programming. We also found out that the only way to do that was to develop our own language, and a language which is called Erlang. In this video we'll show you about the properties of this language and how it's been applied in large prototyping projects, and also about the potentials of this language for the future.
Declarative programming languages have several advantages over traditional languages. For example, programs in such languages are considerably shorter than the equivalent programs in imperative languages. Here, for example, is a program in C. And here is the equivalent program in Erlang. They also encourage clear programming styles. For example, an object-oriented programming style or the implementation of an abstract data type is simple in Erlang. Up to now, declarative programming languages, such as Prolog or ML, have not been used for real-time applications, so we've had to add a notion of concurrency and real-time to our language. We have also added a sophisticated error detection mechanism. This allows us to program robust real-time systems. Declarative programming languages are, of course, also symbolic, and we'll start by showing you the symbolic nature of the language in a typical telephony application.
Erlang is a real-time declarative programming language. But in order to experiment with such languages, you need more than just a computer. You need a real-world application and real hardware to run it on. Let's go into our lab to see how we've done this. And this application is based on telephony. We have programmed an Ericsson MD110 PABX, this PABX you see here, using Erlang. But that's not really quite true, because we've changed the standard MD110 very, very slightly so that it communicates with the Sun workstation. And the Erlang programs we are going to be running are actually running on that Sun workstation, not on the PABX itself. This has been done by connecting the hardware signals through from the PABX to the workstation and vice versa.
Here is our standard Erlang environment. We're running X windows on a Sun workstation. We have an Erlang interpreter window here and an Emacs editor window here.
Okay, let's just make a normal call just to see that the system works.
Hello, Mike.
Hello, Joe. System working?
Seems to be.
Okay, fine.
Okay. Right, we're going to do that again, only this time we're going to look at some of the symbolic information that's available in the system while we're placing a call. I'm going to dial Mike again. 1, 6, 7.
What we see here is a symbolic trace of the communications to and from the number analyzer. It first received the message analyze 1. It returned the result get more digit. It then received the request to analyze the digits 1, 6, and again returned the result get more digits. And lastly, it received the request to analyze the digits 1, 6, 7. It then returned port 67, which signifies a hardware address of a telephone.
I'll now dial an incorrect number. 1, 6, 9.
Here again we see a symbolic trace of the communications to and from the number analyzer. Again, it got the request to analyze the digit 1 and return the result get more digits. Then it got the request to analyze the digits 1, 6 and again return the result get more digits.